assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So here we have a compound like Ma3B3. So these types of compounds, or the compound that has this type of formula, uh, uh, actually shows Fekmar isomerism. So this, since it has a formula like this, it will show this Fekmar isomerism. So let's draw the isomers here. The Fek isomer will be like Fe, then we have our, and then we will have our four of the corners like this, and then we have our, which is going. So say if this is a plane, or this is the, if this is the plane of our on the paper, so this one is going out of the paper and this one is going down the paper. So our, so in case of phase isomerism, or Fek isomerism, which comes from the name phase, in this isomerism three similar, or the three same ligands will take place in the corners of the same phase of this octahedron. So for example, if we just put this chlorides here, here, and here, and we put our carbonyl groups, here, here, and here. And now if we draw a face like this, you see that the chlorines are on the corners of a triangular face. And again, if we just add another face for the cobalts, or for the carbonyl groups, we can see the carbonyl groups are on the corners of another triangular face. So this type of isomerism is called Fek isomerism. And then the another type is Mar isomerism, where, let's just draw it here first. Similarly, we'll have formulas like this. And then we have our front corners, and finally we have on the out of the plane corners. So again, if we just consider this as a plane, then in case of Mar isomers, the three same type of ligands will take place like the corners of a meridian. That is, if the octahedron, or if the complex was a sphere, in that case the same type of ligands will take the corners as it is a shape of a meridian, or like a curve of a the curve of a, or the arc of a sphere. And so let's put our other chloride ions in the other parts. So here similarly, so in case of Mar isomerism, you'll have to put two of the ligands in just 180-degree apart, and another one just in middle, or in the 90-degree with respect to the other two. And in case of the, and see here also we have a kind of 180-degree apart the chloride ions, and then we have the another chloride forming a 90-degree angle with the other two chlorides. So that's how we have to isomers for this formula here. And let's go to the next one. So for this compound, which is a formula of Ma2B2C2. So for this type of compounds, we can have 5 isomers, 5 geometrical isomers. So to memorize or to remember it easily, just remember that first we will put all of these as a trans, or first we will put all of them as a cis isomer. So let's write our first one here, Mn. We are just drawing it like this. So we'll have all of the ligands in cis positions. Like cis means they will be adjacent, not 180-degree apart. So any other angle other than 180-degree between the same type of or same kind of ligands will be considered as cis ligand or cis isomer. And then let's put the Cl, and then we put bromide. So all kind of the so all type of this here will be have they're adjacent to each other, and that's why it's a cis type of isomer. And then that's our first type. And then in the second type, we will have all type of ligands in transposition or 180-degree angle position. So we put our carbonyl groups in 180-degree apart position or in transposition. Then we have our chloride ions in 180-degree apart position or transposition, and finally we have our bromides in 180-degree or transposition. So this is our second isomer. And then for the rest of the three, what we will do, we'll just put any one of them in transposition or 180-degree angle position, and we'll just put the others in cis position. So how will you do it? Let's see. First we put our central metal atom, then we put our, so for the first case, let's put carbonyl group as 180 degree apart, and then we put the bromides in cis position and also the chlorides in cis position. So that is our third one. Then for the fourth one, let's put manganese in the middle, and then we have our 6 corners. So in this time we will put chlorine as in trans or 180 degree apart position. Then we put our carbonyls in cis position and also our bromide in cis position. That is our fourth isomer. And the fifth one, what we'll do, we'll just put the bromides in 180 degree apart or in transposition. So we are putting our bromides in transposition, and then we put our carbonyls in cis, also chlorides in cis. So that's how we have 5 different isomers for this formula here.